Okay, sorry. Homework 1 and 2 here is this worksheet front and back. I'm just gonna go over a couple in each section. This first section 1 through 12 is asking really for you to combine like terms. And I put a little note here that like terms have same variable and same exponent. So you should already be familiar with something like number 1, -3a and 52a. So we're just adding these two coefficients, the number in front. This comes out to be 49a. Now, when I jump to a problem like number 2 here, we have two variables, an x and a y. So I have to check to make sure they have the same exponent. So x squared y and x squared y. So they are the same. These are like terms. So we're just now keeping that. Don't change that. We're now just addressing the coefficients. The -2 minus 3. Well, -2 minus 3, that's going to give me -15. And I'm going to keep my same like terms. So the x squared y is going to stay. We don't add anything or change anything with the variable or the exponent. Another example could be here on number 15 here. If I look, c squared d squared, c squared d squared, these are like terms. And then all I'm doing is now subtracting the coefficient of 11 minus 20. That's going to give me a -9 c squared d squared. Now, if they don't have like variables, like number 6 here, this is a AB, and then if I go to the next, this has a BC. These are not like terms. So if they're not like terms, then that is your answer. There is nothing else we can do here. We just keep 4A plus 13BC. This is the simplified answer. Okay. So when you get to this bottom, just make sure your order, pay attention to it. It says subtract a -2 from a -8. So I said -8, -2x. So we have a -8x minus a -2x. Okay, make sure you're writing it like you're reading it. This would actually come out to be -6x. Okay, and so that's the first half. The second half here, 13 through 25, I believe. Yeah. This is asking you the product rule of exponents right here. So basically, it's just saying that when we multiply like terms or like exponents, when we multiply exponents, we add the exponents. So whenever we multiply, we're going to end up adding the exponents. I'm just going to abbreviate here. So, like for example, if I jump into 14 here, here's my x to the 3rd and x to the 8th. You keep the x, let me just change my font, sorry. And the exponent, which is 3 and 8, those get added. Then I go to the next variable, which is my y's here. This is y to the 5th, and now I'm adding that 10. So when I simplify this, this is just going to end up being x to the 11th power and y to the 15th power. Okay, so just remember to add your exponents. Now, if there is a number with your term, you multiply those numbers. So like on 16 here, we have a 5, -3, and a -2. So we're multiplying those together, and this will give me -15 times 2, +30. Then I go to my variables, my like variables. I'm going to just go in order in the way it's written here. We have an a next. And so if I'm dealing with a's, here's the next a right here. This a does have an exponent. It's like an invisible 1. So we're saying a to the exponent of 1 plus 2, because whenever we're multiplying, we add the exponents. Now I go to the b. This b has an exponent of 1. So we have a 1 and this exponent of 3, so we're adding those. So when we simplify this, this is 30, a to the 3rd power, b to the 4th power. Okay. So anything with numbers, you're just going to have to multiply them together and then add your exponents for each variable. So same here, like on 20. Don't let the fraction fool you. If I do 5 times 1/5, that's just going to leave me with 1. Then I go to my a's. To the second power plus this times this a to the first. That's going to now give me an exponent of a 3. Then I go to the b's. I have one b here, so exponent 1, another b. It gives me a total of b squares. And then I go to my c to the third, to the fourth, that's c to the seventh. So I can keep my 1, or I don't necessarily need that invisible 1. Sorry. So I could leave my answer like such as well as the same. Those are the same answers. And then this last section is requiring you to do a combination. Remember, multiplication comes before adding or subtracting. So on a problem like this here, if I was doing 22, I would multiply my coefficients. So this is 21, a actually squared because it's to the first, b. Then I'm going to subtract it from 4a squared b. And now when I look at these are like terms. So I can now simplify them by subtracting the coefficient. So this actually comes out to be 17a squared b. You keep the variable, you don't change that. We're just changing the coefficient. So multiply first. So this would be 8xy to the 5th power plus, oops, forgot to multiply the 3 and the 8xy to the 5th plus 15x y to the 5th. And these are like terms, so then we're just adding them together to get 23xy to the 5th. Okay, so that takes care of that side. And then if we go to the other side, this is all power rule. Okay, so here we're going to have to multiply the exponents. Okay, make sure you distribute the power to each exponent, to each term. Okay, distribute the power to each term. When I'm saying power, I'm referring to that exponent. Okay, so let me just change my font again, sorry. So here I'm distributing to this 2 to the 4. And whenever we distribute a power to a power, we end up multiplying those exponents together. So x to the 8. Most of you had added that already. It's when you have now a number, a coefficient, like number 4 here. We have to distribute to each term. So this 3 is now going to have a power 4. And this y to the 3rd power now gets multiplied by that 4. So when we simplify this, we can keep the 3 to the 4th power, but I can put that in the calculator, and that turns out to be 81. And this would be y to the 12th power. Okay. So distribute your exponent to each term inside the parentheses. So like for a problem like number 8 here, I'm distributing the 4 to the a and to the b. I have a negative a to now to the 36th power because I'm doing 9 times 4, and b to the 4th power. Okay. This actually is going to turn into a positive a, and we haven't really discussed all the way fully about this, but there's a shortcut on this. If my exponent is even and I have a negative side, all even exponents turn into a positive. Okay. If it's odd, then it will be negative. Okay. So you want to distribute the power to each term. So like on something like number 9 here, it's 1/2. That's going to have a power of 7. And then x to the 28th power. And then we can put this in the calculator and simplify this. I think it comes out to be 1/128, I think, something like that. Okay. Now, if the number is outside the parentheses, that's multiplication, but you still got to do exponents first. Okay. Exponent, just like PEMDAS, we're going to distribute. So I have this negative 6 here outside the parentheses. Now I'm distributing the 8 the 3 to each term. So this 2/3 is going to be raised to a power of 3. And this p to the 8th power now gets multiplied by that 3. And that's going to stay. So when I simplify this, a -6 gets multiplied. 2/3 to the 3rd power is 8/27. And this is p to now the 24th power. So now we're just going to multiply these two numbers, a -6 and 8/27. That comes out to be a -16/9 p to the 24th. Okay. It looks really crazy, but it's -16. This is going to be a fraction. I'm sorry, over 9. And then your variable is just next to the fraction to the 24th power. And then this last section, we just have a combination here. So anything with an parentheses and an exponent, like here on 13, this one you're going to have to do first. Then multiply. So like I'm going to do all my power rules first. Exponents come before multiplication. So here on 13, this would be m to the 35th power and to the 21st power. Now I'm multiplying that to m squared n. And now because we're doing multiplication, we're adding the exponents. So this will become m to the 37th power n to the 22nd power. Okay, so do your exponents first. If you have two exponents, I don't mean powers, like parentheses to an exponent. Like here, I have 2 of them, so I need to do both first. Distribute, so this is like 2 to the 3rd power, x to the 9th power. I just went ahead and multiply that. Y, instead of showing it, this is y to the 6th, and z also to the 6th. I'm multiplying that to raising this second term to a power of 4. So this is x to the 8th power, z to the 4th power. Now we're adding the exponents. So we keep the 2 to the 3rd power. That's just going to give us 8. 9 plus 8 is going to give me 17. So this x is to the 17th power. We don't have a y to the 6th to be added to anything, but our z is going to go to the 10th power. Okay, hopefully this helps you to get this done. We will have an activity to go over that correlates with this skill. So you need to practice so you can be able to do your little puzzle and game tomorrow. All right, thanks.